This is a video lesson for Algebra Honors Unit 2, Day 8. We'll be solving inequality statements that have absolute values in them. So remember, absolute value inequalities are compound inequalities that will have and statements, or they will have or statements in them. And so what we're going to do is figure out for each statement that we have whether it's talking about and or, and then we're going to solve down for a specific variable. Remember, when we solved absolute value equations, we always wanted to isolate and split. And so we're going to do that with inequalities as well, but it's just a little bit more complicated. First, we're going to isolate our absolute value, and then we're going to identify whether we have an and statement or an or statement. And then we'll set up our two inequalities. So where we used to split into two directions before, this time when we split, we're going to keep everything the same and just get rid of our absolute value bars for the first inequality statement. But for the second one, we're not only going to get rid of our absolute value bars, but we're also going to change the direction of our sign and then make the whole other side of the statement negative. So I'll walk through and show you what I mean. Once you have those two statements to solve for, you're just going to work backwards using inverse operations and come up with the possible solution sets for your variables. You should always check your work by plugging in whatever numbers you believe are true in your original statement. Go back to the original statement. Okay, and just remember, like with an inequality statement, with an inequality equation, when your absolute value equations are all written out and you've isolated the absolute value, that absolute value has to be greater than 0, right? It has to be a positive number. Same with an inequality. We can't have the absolute value bars on the left side. We can't have those be less than a negative number. So I'll try to show you all of these things as we go through the notes. Okay, things to remember when you're using inequalities. If you multiply or divide both sides by a negative number, it has to be negative. It's not just multiplying. If you multiply or divide both sides by a negative, you're going to need to flip the signs. Okay, so the solutions for an and inequality, if I tell you it has to be greater than 2 and less than 6, then it means both of those pieces of information have to be true. Any variable, or rather any value I want to plug in for that variable has to be true for both statements if it's an and statement. Okay? And if I have an or statement, oftentimes those are going to go in two different directions on my number line, and I just need for my value to be true for one of them, one or the other, or maybe both, but one or the other. Okay, so just try to keep track of your and your or. All right. Just like with equations, inequalities can also have special cases. It can be that any x value that I plug in, or rather any number that I plug in for my variable, will give me a true statement. So if I solve and I end up with something that's always true, like 3 is less than 6, then I know my solution set is all real numbers. No matter what I plug into the inequality statement, it's going to be true. But if I solve down for my variable and I get something like -2 as greater than 9, that's not true, right? That's not ever going to be true, and so that means there is no number that I can plug in that would give me a true statement, and so we would say no solution. Okay, let's look at some problems. Okay, so basic absolute value stuff. A math magician comes to your younger brother's birthday party and says, "I'm thinking of a number whose absolute value is 5. So on this number line on the right, I'm going to show you some number whose absolute value is 5. Well, 5 has an absolute value of 5 for sure, right? But so does -5. So those are my two options, right? The absolute value of -5 equals 5. And of course, the absolute value of 5 equals 5. So those two things are true. Now that math magician says, "I'm thinking of a number whose absolute value is less than 5. So here's where we make this an inequality statement. Okay, so the first thing I'm going to think about, I need a number whose absolute value is less than 5. So I'm going to call it x, right? I've got some x, and I'm saying the absolute value of x has to be less than 5. So if this is 5 on my number line, 4 is less than 5, right? And 3 is less than 5, and 2 is less than 5. So I know some of these numbers, and actually I can even say, as long as I don't touch 5, I can have an open circle there. And so I'm getting smaller. But I have to be careful. I have to be careful because I already talked about how the absolute value of negative 5 is also going to be 5. So I'm just going to think through this logically a little bit. If x is negative 6, the absolute value of negative 6 is positive 6, and 6 is not less than 5, right? So I just have to be careful here because I actually can't get any bigger than negative 5, and I can't get any bigger than 5. So I'm going to come over here and I realize I can't actually be negative 5 because the absolute value of negative 5 is 5, and 5 is not less than 5. But I can be the absolute value of negative 4, because the absolute value of negative 4 is positive 4. So I can have that number, and I can be the absolute value of negative 3, because that's just 3. So I have all the things that are in between negative 5 and 5. See how that works? This mathematician said the absolute value is less than 5, so all of these numbers in between negative 5 and 5 would be true if I plugged them in as my variable. All right, so finally that mathematician says again, the final number I'm thinking of has an absolute value greater than 5. Well, here's my 5 that I care about. I want absolute value to be greater than 5. So it's going to be all of the numbers getting bigger there, right? The absolute value of 6 is greater than 5. The absolute value of 7 is greater than 5. But we already established right here that I can use some of my negative numbers as well. So I'm going to think about what this looks like. This looks like the absolute value of that number is greater than 5. And so if I think about it over here, if I think about negative 6 as a possibility, the absolute value of negative 6 is 6, and 6 is greater than 5. So I know negative 6 works and negative 7 works, okay? If I have anything that's just a little bit bigger than negative 5, open circle there because I can't actually be negative 5, I'm going to go all in the left direction. I'm going to negative infinity that way. And so you can see that this statement up here, I have included everything in the middle, and whatever value I choose has to be true in the middle here. Over on this example, I have two different statements that are going in opposite directions. Okay, so we've already talked about this, graphing a solution set for each inequality down here below. If the absolute value of x equals 5, this is an equality statement, this is an equation, right? If the absolute value of x equals 5, I'm going to isolate. It is isolated all by itself, and I'm going to split. Remember this? I say x equals 5, or x equals negative 5. Both of those are true. And so I'm going to come up here and say x equals negative 5, x equals 5. Those are my two exact answers that I can have for this equation. Okay, if I say the absolute value of x has to be less than 5, I'm going to isolate and split. Here's where we do something a little bit different. I'm going to isolate. It is isolated already, that absolute value bar. And now I'm going to split. I'm going to say that I have x is less than 5. Exactly like I had it before, but I got rid of the absolute value bars. When I split, up here when we did the equation and we split, all we did was we made the right side negative. But I have to do some different things here because it's an inequality. And so I'm going to say that this is x is greater than negative 5. So I had to flip and change the sign. Flip and change the sign. So now I know x is less than 5. So here's 5, and x is going to be less than 5, going in this direction. And I know x is greater than negative 5. So here I have x is negative 5. I can't actually equal negative 5. It's an open circle, so I'm going to go that direction. Okay, and so these overlap in the middle. All of the things that are on that solid blue line count as solutions. And I could just pick something random like -2 and plug it in if I want to just check my work. And so I say the absolute value of -2 is less than 5, and sure enough, 2 is less than 5, so that's true. All right, now we want to do the absolute value of x is greater than 5, and I'm going to isolate and split, and then I get to do some fancy footwork because I'm working with inequalities. Isolate and split. I have x is greater than 5. All I did on the left side was get rid of those absolute value bars. On the right side, I'm going to say x. I'm going to flip my sign and make that 5, the opposite sign is going to be -5. So I have x is greater than 5 here. X is greater than 5. Or x is less than -5. So we're going in that direction. Okay, always isolate and split. The only things that are different for 4 and 5 is now I have or equal to on here, and so I'm going to split. I have x is less than or equal to 5, and I have x is greater than or equal to -5, and now I'm going to graph that. +5 right here. It's a solid circle because I can include it, and I want x to be smaller than that, so I'm going in this direction. Here, x is greater than or equal to -5, so here's my -5, and I want x to be bigger than that. Okay, and so I want the whole lot of information that is in between -5 and +5. If the absolute value of x is greater than 5, then I'm going to split it. I have x is greater than or equal to 5. I hope I said greater than or equal to a second ago. And I have x is, I switch the direction of my sign, less than or equal to -5. Okay, so we're going to isolate, split, and then on one side we have to flip and change. Okay, so x is greater than or equal to 5. Here's 5. X is going to be greater than or equal to 5. My other option is x is less than or equal to -5. And so I'm going in that direction. Okay,